All right. So today we're going to do 5.2, which really today we're just going to verify. Okay, so again, I have a few kind of hints or tips for you that I think will be helpful. The first, so I don't know, let's just call this hints again. The first thing is, we've talked about this before, you work on only one side at all times. Okay, that's really important. Alright, so only one side at a time. Okay? Hint number 2, look for opportunities to factor an expression, add fractions, maybe square a binomial, or use the conjugate. Okay. Number 3, look for opportunities to use the fundamental identities. So again, at this point you should have your formulas memorized. I mean, they were from last chapter, so you honestly, you should have already had them memorized. But in case you didn't, at this point I would expect everybody to know them all. If you don't, let's get them locked in tonight, okay? Then, this is like a last resort, because it usually takes the longest. When none of these work, make everything sine or cosine. Okay, so again, just go back to those basic building blocks of sine and cosine. It might take you longer to do it this way, but it might be the only way to get there, okay? The most important thing is never give up, okay? No, seriously, you can laugh, all right? This is like a public service announcement, all right? Never, ever give up. Always try something. I noticed some of you aren't writing this down. Not sure why, since this is in all caps. It's the most important thing, okay? You know what? It's now highlighted too, okay? It's really, really important, all right? You can always try something. So, like, if you've tried the problem 3 times, try it a 4th, okay? Rewrite it, try it again with a different approach, all right? So maybe another piece of paper. Don't even look at what you did before. Take another approach, just don't give up. Okay, you ready to try some examples then? All right. We're just going to verify today. So, example 1. We're going to start with cotangent squared of theta over 1 plus cosecant of theta equals 1 minus sine of theta over sine of theta. Okay, so looking at this, I don't know that there is necessarily a more complicated side to work on. Okay, so it could be your choice on which side you choose, either the left or the right. You don't always have to choose the left side. Okay, it kind of just depends what you're feeling. All right, so what would you like to do? Would you like to choose the left or the right? I would also like to choose the left. And like I did yesterday, I'm just going to kind of, or the day before, I'm going to make this like thinking column. This is just kind of some of the things I'm thinking. This is not stuff I would necessarily have to show, the work I'd have to show, but this is just kind of where my mind's going. When I see cotangent and cosecant together. Right away, I'm thinking about the identity. Do you know what identity I'm talking about? 1 plus cotangent squared of theta equals cosecant squared of theta. Everybody agree with that? That one you should know, okay? Now, what I see here is that I have this 1 plus cosecant, okay? Now, I know that if I manipulate this, cotangent squared of theta is cosecant squared minus 1. Agree? If I was to substitute that in here, isn't that a difference of squares? I could factor it, and then I could see those canceling. Okay? So that might be a place to start. All right? Now remember, we're not just trying to simplify. We're trying to get to this. So at some point, I'm going to have to introduce sign into this. All right? But for now, that's where I would like to begin. Is that okay? Okay. So that's what I'm going to do. You don't necessarily have to show any of this. You can, if you show this, show it on the side, just like I am, okay? But we're going to substitute in. And remember, every single step needs to be shown, and you need to make sure that you write down that other side of the equation with each step. Okay, these problems are pretty formal in their work. Okay, so now at this point, I can factor. Okay, so this is going to factor to cosecant of theta minus 1 times cosecant of theta plus 1 over 1 plus cosecant. Okay. All right, what should I do next? Cancel. So at this point, I have a much simpler piece to work with. Okay, now I want you to think about what could be our next step. So I'm having to introduce sign at some point. Joey?
1 over sign?
Yeah, so cosecant's 1 over sign. That would be a really good way to introduce sign into this. Okay. Anybody see how we're going to finish this out? Go ahead, Arwa. Yeah, so like 1 is like 1 over 1, and if I get a common denominator, then I have the whole thing over sign, don't I? So I'm going to multiply this piece by the sine of theta. So I end up with 1 minus sine of theta over sine of theta, which is where I was trying to go. All legal moves, all of my steps are shown. That way my reader can follow my thinking, okay? So this is what I'm expecting from you on a verifying problem. Are there any questions about this one? Everybody okay? Okay. All right, well, let's try another one. Can I move this? Yeah. You know what? Here I'm going to make a note to introduce sign. Okay. Example 2. How about tangent to the 4th of x equals tangent squared of x times secant squared of x minus tangent squared of x. Okay, so we have to choose the more complicated side. So this time we should probably choose the right. Agree? Okay, so I'm just going to mark it. That's the side I'm going to work on. So that means every step should say equals tangent to the 4th. All right, what do you want to do? Factor. You see that common term there? You see that GCF? That tangent squared. Okay, I want to factor that out. So I'm going to have tangent to the 4th x equals tangent squared times secant squared minus 1. Everybody agree with that? Okay. All right. So, yeah. So, now what can we do? I'm trying to get to, I need 4 tangents. Ryan.
There's a Pythagorean identity that if you manipulate can become make secant squared x minus 1 tangent squared.
Yes, that is correct. So 1 plus tangent squared is equal to secant squared. That means I can manipulate this. So tangent squared of theta is equal to secant squared minus 1. Everybody agree with that? So I'm going to substitute that in here. Okay? So I have tangent to the 4th x equals tangent squared times tangent squared. Right? This is equal to tangent squared. And now tangent squared times tangent squared is tangent to the 4th. This is a very easy one. Okay? To kind of give you an idea, remember we have a quiz on Monday. There are going to be 4 simplifying problems and 2 verifying. Okay? This would be way too easy for one of the verifying problems. Okay, on the quiz, just to give you an idea. This would be a much better representation of kind of what we're working with. All right, now we're going to get there. Okay, this is only day 1, but yes. Yep, and we'll talk more about it later too. Okay, you want to try one? You ready to try one? You and your partner? Okay, how about sine cubed x cosine to the 4th x equals cosine to the 4th x minus cosine to the 6th x times sine. I'm going to give you a hint, if that's okay with you. Try the right side. Okay, so try the right side, and you and your partner figure out what you got to do there. It's going to be super fun.
Can I see something?
Yeah, and ask our walk for us because I can't move this right now. Sorry. Here, you can use this. Use that. Just give it back. Yeah. Okay. So it looks like a lot of you guys got it. What'd you do first? Yeah, you took out a cosine to the 4th. Okay. So everybody check your work. Make sure you have that left side written down each time. So if I take out a cosine to the 4th, I end up with 1 minus cosine squared. Okay. What's this equal to? Sine squared, right? Okay, so I plug in that sine squared. When I multiply those together, don't I get my sine cubed? Pretty easy, right? It looks complicated, but it ends up being just a couple simple steps, okay, with a really common identity. Okay, yes?
Is it okay if like, I move the sign next to the cosine to the 4?
Yes, it is. Mm-hmm. Jake?
So like you don't have to have the...
No, it's okay. We can see that those are the same. Yep. Okay, example 4. Okay, so how about secant? I don't know if I'm going to have enough room here, you guys. I'm going to turn the page. I don't think I'll have enough room. So, secant of x plus tangent of x equals cosine of x over 1 minus sine. Okay, so take a look at that for a second. Any thoughts on what we could do first? Go ahead, Jake.
So could you square both sides?
You can't work on both sides. That's illegal. Okay, so no. Yes, Jerome.
If you can't work on both sides, then in what situation would we be able to use the conjugate?
Right now? Yeah, we could use the conjugate right now. We just can't work on this side too. So, Jake, your suggestion was to square this and this, correct? Yeah, you can't do that, but we can multiply this side by the conjugate. And that's where I would begin too. That's what I saw. So I'm going to work on the right side, and we're going to multiply by the conjugate. Kelly?
How do you go on the right side?
I'm actually going to show you an alternative to this problem next, okay? So it just kind of depends what you see from the beginning.
So it doesn't matter.
It doesn't matter. Sometimes you can get to it, on either side. Now go back to example 2. It'd be really hard to take the left side and take it to the right side, right? But in a situation like this, where there's, stuff to work with on both sides, sometimes it's possible, okay? So I'm going to show you this way first, and then we will do the left side next, okay? So let's multiply by the conjugate. Okay, so I have cosine of x times 1 plus sine over 1 minus sine squared of x. Okay, well what's 1 minus sine squared of x equal to? Yeah, cosine squared. Okay, so now I have cosine x times 1 plus sine of x over cosine squared. Can you see how this is going to end? Start being able to predict what's coming. Okay, so we're going to cancel those cosines. So I have 1 plus sine of x left over cosine. And now what? Almost there. Yes, you can split this. Do you see how you can split this into 2 fractions? Okay, so secant of x plus tangent of x equals 1 over cosine plus sine over cosine. Well, what is 1 over cosine? Secant. And what's sine over cosine? Tangent. And now we're done. Okay. Alright, now let me show you what if you wouldn't have started with the right side and you would have started with the left side instead. Okay, so I don't think I'll have room to do it here. So I'm going to turn the page. Can I turn the page? Everybody okay with that? Okay, so this we'll just call, I don't know, example 4b. Okay, so let's say that, we started out with secant plus tangent equals cosine over 1 minus sine. Okay, and this time we want to work on the left side instead. Okay, now if I was to choose the left side, I would want to think right now, how could I introduce cosine and sine? I already agree that those are reciprocal functions, right? Like I could introduce secant with 1 over cosine and tangent with sine over cosine. Okay, so that's where I'm going to start. So this is going to be 1 over cosine plus sine over cosine. Okay. So right now they already have a common denominator, so I'm just going to combine them into one. Okay, so they kind of look similar. They're flipped and there's a different sign. So where do you think you're going to have to go here on the left side? Remember, we're only working on the left side now. We're not going to touch the right. So what can I do here? Just flip it? That's illegal.
It'll be one.
It's not the same thing.
One minus.
Can't do that. No flipping. Ryan.
Separate the fraction.
If I separate the fraction, I'm in the same step I was just in. That's okay. That happens lots of times. Tanner.
Multiply by their conjugate.
Multiply by the conjugate. So I'm going to multiply by 1 minus sine. Now, this is going to introduce that 1 minus sine in the denominator where I need it. Okay? So now I have 1 minus sine squared of x over 1 minus sine times cosine. Alright, now what do I do? How about this numerator here? I don't want to factor it, otherwise I go back to where I started. Yes, change it to cosine squared. Okay, and now those cosines will cancel, leaving me with cosine of x over 1 minus sine, which is what I need. Now you'll notice that in both approaches you really had to do kind of the same steps, right? We had to multiply by the conjugate, we had to introduce that Pythagorean identity, we had to cancel the terms. So a lot of times that happens, but kind of just depending where your mind goes with it first is how you would have to approach it, okay? Are there any questions? Let me see if there's anything else I want to talk about. I don't know why I have that twice. Okay, so that, yeah. Noah, you have a question or you're good?
No.
Oh, okay. Any other questions?